Assalamualaikum warahmatullahi wabarakatuh. Selamat Hari Raya Aidilfitri. So today we are going to learn about ratios and graph of trigonometric functions. Okay, so what are you going to learn in this chapter? First is the value of sine, cosine and tangent for angle theta between 0 degree until 360 degree. Next, which is next week, you're going to learn about the graph of sine, cosine and tangent function. Okay, basically, why do you study this chapter? When are you going to use this chapter in your future? So engineers use graph of trigonometric functions in the construction of concert halls to measure sound strength so that the sound is clearly heard. Okay, so another career that is using trigonometric function is geologists. They use graph of trigonometric functions to help them understand the formation of verdict pattern of earthquakes and wave. So they will give you the warning if they found there's chances of tsunami or earthquakes or a big wave like that. Okay, so let's move to the first subtopic, the value of sine, cosine and tangent for theta in between 0 and 360 degrees. Okay, first thing is the unit circle. Okay, so this is a unit circle. Here you have quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Okay, a unit circle is basically a circle with radius of 1 unit. Okay, so the radius here is 1 unit. Can you see here? 1, -1, -1 and 1. So the radius is 1 unit and it is centered on the origin of the Cartesian plane, the x and y axis. Okay, it is given that P is a point that moves along the circumference of the unit circle, and theta here, theta is the angle formed by the radius of the unit circle OP from the positive x-axis in an anti-clockwise direction. Okay, so it is this. A unit circle. Okay, theta. Okay, theta is the angle formed by the radius of the unit circle. Here's the origin. Here's the moving point P. So that's the radius. And from the positive x-axis. Here is your x-axis. Here is your y-axis. Positive x-axis on this side. Here is your positive x-axis. So here is the angle theta. Okay, in an anti-clockwise direction. So we measure it in an anti-clockwise direction. Anti-clockwise. So we go there. Okay, so if point P is in quadrant 2, then that means the theta is in between 90 and 180 degrees. Okay, so like this. For example, okay, your P is here. Okay, OP. So here is the theta. Theta is in between 90 and 180. If the point P is on quadrant 3, that means the theta is in between 180 degree until 270 degree. If it is in quadrant 4, then the theta is in between 270 degree and 360 degree. Okay, so that's the unit circle. Oopsie. Okay. 6.1.1 to make and verify conjecture about the value of sine, cosine and tangent for angles in quadrant 2, 3 and 4 with the corresponding reference angle. Okay. What does it mean by corresponding reference angle? corresponding reference angle is an acute angle. Okay, is an acute angle which is always less than 90. Okay. Acute angle always less than 90 degree. So angles in quadrants 2, 3 and 4 have corresponding reference angles alpha. The angle in quadrant 1 itself is the corresponding reference angle. So if it is in quadrant 1, then the corresponding reference angle equals to the value of theta. So do you still remember the theta is the angle between the radius and the positive x-axis when we measure anti-clockwise. Okay. So example 1, determine the quadrant and the corresponding reference angle for each of the following. 138. So 138, in which quadrant is it? In which quadrant? In the second quadrant, because the value is in between 90 and 180. So 138, it's basically like this. Okay, 138 degree. Okay, so the corresponding angle is corresponding reference angle alpha is 180 minus 138 degree equals to 42 degree. Okay, so this is the corresponding reference angle. Okay, so for 239 is in the third quadrant. Let's see like this here, 239 degrees. Okay, so in the third quadrant, just now in quadrant 2, quadrant 2. Okay, third quadrant, and the corresponding reference angle is 239 minus 180 equals to 59 degree. Okay, so it is here, corresponding reference angle. 312 is in the fourth quadrant. Okay, fourth quadrant, and the corresponding reference angle is 360 minus 312 equals to 48 degree. Okay, so we need to know the value, the correct corresponding reference angle, so that we can calculate the sine, the cos, and the tangent of any angles given. Okay, example 2, state the relationship between each of the following trigonometric functions with its corresponding reference angle. So what kind of relationship here? So sine 167, it is in quadrant 2. Okay, 167 here, sine. Okay, sine 167 equals to sine 180 minus 167. So equals to sine 13. Okay, well, why do I say sine 167 equals to sine 180 minus 167? It's because of the relationship just now. Okay, so we know that the angle, the corresponding reference angle for 167 is 13. So that means if you want to find the value of sine 167, we can use the value, the angle from the corresponding reference angle, which is 13. Okay, Next, cos 258. 258 located in the third quadrant. Okay, third quadrant. So cos. Okay, basically, you need to know this formula. Okay, ASTC, add sugar to coffee. Okay, what formula is this? It is actually an acronym. Acronym use. If I'm not mistaken, I have it somewhere here. Here. The smart tips. Quadrant 1, all positive. Quadrant 2, the sine theta is positive. Quadrant 3, the tan theta is positive. Quadrant 4, the cos theta is positive. So the acronym that I use is ASTC, add sugar to coffee. So I remember the value of cos just now. What cos was that? Cos 258 is negative. Okay, it's a negative value. So cos 258 equals to the negative cos of 258 minus 180. Okay, 258 minus 180 equals to 8, 7, negative cos 78. So that's the relationship. Okay, and the last one is tan 349. Can you do that for me? 349 is located in quadrant 4. Okay, so 349 here. So tan 349. Tan in fourth quadrant is negative. Okay, here all positive, only sine positive, only tan positive, only cos positive. So tan in the fourth quadrant is negative. So negative tan 360 minus 349. Okay, equals to minus tan 11 degree. Okay, so that's the relationship. Okay, if I can show you from the textbook. Where's the textbook? iPad. Here. Which is that? Here, the relationship. Okay, so the relationship between the function of sine, cosine and tangent for angles in quadrants 2, 3 and 4 with the corresponding reference angle can be summarized as follow. So this one actually you don't need to memorize, you just need to understand. In quadrant 1, all the trigonometric functions are positive, sine, cos, tan. Quadrant 2, only sine is positive. Quadrant 3, only tan is positive. And quadrant 4, only cos is positive. Okay, so let's get back to the PowerPoint. Okay, this one we can use the coordinates. Okay, so for example here, when you want in quadrant 1, if you want to calculate the value of sine theta in quadrant 1 is the y coordinate. The cos theta is the x coordinate, and the tan theta is the y over x. In the second quadrant, the sine theta is the y coordinate, the cos theta is the x coordinate, but our x coordinate now is in form of negative, so we use negative x, and the tan is y over negative x just now, so that's why our tan is negative. Okay, in the third quadrant, here we have a point negative x, negative y, so that's why our sine negative, our cos negative, but our tan is positive because we divide negative y over negative x. Okay, so that's why we got positive y over x here. And here in the fourth quadrant, we have a positive value of x, so that's why our cos here is positive. Then our sine is negative, that's why our tan is negative. I hope you can understand this table, and if you don't, then you can just ask me during the class. Okay. 6.1.2, determine the value of sine, cosine and tangent for angles in quadrants 2, 3 and 4 based on the corresponding reference angle. Okay, how do we determine the value? So we determine the positive or negative sign for sine, cosine and tangent for angles in quadrant 2, 3 and 4. Okay, so for example here, determine the value. How do we determine the value for the first one, sine 104? Okay, sine 104 is in the second quadrant. So it's sine 180 minus 104 equals to sine 76. So you just press your calculator. Sine 76 equals to 0.9703. Simple, right? Okay, cos 208.2. 208.2 is located in the third quadrant. So third quadrant, add sugar to coffee. So third quadrant here, so the cos is negative, right? Okay, cos is negative. Okay, wait, we use other colors, blue color. So cos 208.2 degree is a negative cos of what? 208.2 degree minus 180. So the reference angle is 28.2 degree. So next we use our calculator. So we got negative 0.8813. And last one, tan in the fourth quadrant is still a negative. So equals to negative tan 360 minus 3187. So negative tan 41 degree 43 minutes. So equals to negative tan 41 degree 43 minutes. Negative 0.8915. Negative 0.8915. Okay. So that's the value for A, B and C. Next, how to determine the value of sine, cosine and tangent for angles, for special angles, angles 30, 45 and 60 degree. So again, you need to remember the concept. Okay, why do we call them special angles? Because we can get the value by drawing a rectangle. A rectangle here. Oopsie. A rectangle. Okay. So here 60, 30. So 2, 1. Here is 3. So cos 150 and one more is a 45 degree. 45, 45. So since we have 245 here, the side is 1, 1 and set 2. One here and one there. Here is the set 2. Okay. Cos 150. So 150 is here. 150. So that means the reference angle is 30. So cos 30. Cos 150 equals to cos 30. Is the value positive or negative? So in the second quadrant, add sugar to coffee, cos is negative. So negative cos 30. Cos 30 cos adjacent over hypotenuse. Okay. So cos 30 is actually set 3 over 2. So it's negative set 3 over 2. Okay, tan 225. 225. 225 in which quadrant? In the third quadrant. Okay, third quadrant. Here. 225 degree. Okay, so the reference angle is 225 minus 180 equals to 45. Tan in the third quadrant is positive, so tan 225 equals to tan 45. Tan 45 equals to opposite over adjacent. 1 over 1 equals to 1. Okay. Sine 300. Sine in the fourth quadrant is negative because only cos is positive. So sine 300 equals to negative sine 360 minus 300. So equals to negative sine 60. Sine 60 set 3 over 2. So negative set 3 over 2. Okay. Next, determine the angle when the value of sine, cosine and tangent are given. So this one basically we just use calculator. Okay, given that sine theta is 0.6157 and the theta is in this range 0 to 360, calculate the angle. So use your calculator, and then that means we have two different value of theta because 38 positive sign, that means it's either in the first quadrant or second quadrant. So this one is the value for the first quadrant, and this one is the value if the theta is in the second quadrant. Okay, 1, 2. Okay, next, how to solve problems involving sine, cosine and tangent. In the diagram on the right, QRS is a straight line given that QS equals to 8 and QR equals to RS. Calculate cos X and tan Y. Okay, X here is located in the fourth quadrant, right? Because the value of X is in between 270 and 360 degree. So in the fourth quadrant, the value of cos is negative. Okay, cos X. So QS equals to 8. That means here we have 4 and 4. 3, 4. That means PR equals to 5. So cos X actually negative cos of 3 over 5. Oh, sorry. In the fourth quadrant, cos is positive. So positive cos 3 over 5. Positive cos. Okay, cos X equals to positive cos of angle PQR. Okay, So angle PQR, the cos is 3/5. Okay. Tan Y. Tan Y is in second quadrant, and tan in second quadrant is negative. So tan Y equals to the negative tan of angle PRQ. So the PRQ here, tan opposite over adjacent, opposite 3 adjacent 4, negative 3/4. Okay, last one, example 8. A group of students produces a robotic arm with a length of 15 cm, as shown in the diagram on the right. The robotic arm is programmed to move an object from point P to point Q, given that the cos theta equals to blah blah blah, and calculate the angle and the distance between P, Q. Okay, so we are going to calculate the angle theta and the distance between point P and point Q. Okay, we know that cos theta equals to negative 0.866. So the theta is cos 6. Okay. Cos 0.866 equals to 30 degree. So theta is 30 degree. Calculate the angle theta. That means theta is 90 plus 30. Sorry, it's not 90 plus 30. Okay, so the reference angle is 30. So theta is 180 minus 30 equals to 150. Okay, so the 30 stay there. Okay, the 30 is here. So the theta is 180 minus 30 equals to 150. Okay, next to calculate the distance between point P and Q. So point P and Q, the distance is like this, PQ. So how are we going to cut that? So first, why don't we try using right angled triangle here? Okay, we have 15. 15 for the radius of the arm. Okay, 15, 30, 15 here, 30. So the height, let's say the point here is point R. So the height QR is we know the length of the hypotenuse, so and we want the value of the opposite, so we use sine. Okay, sine 30, sine opposite over hypotenuse, opposite the QR, and hypotenuse is 15, so QR is 15 times sine 30 equals to 7.5 cm. Okay, 7.5. And the OR O stands for the origin, so OR is the adjacent of hypotenuse over 15 equals to cos 30. Okay, so OR is 15 times cos 30 equals to 12.99 cm. So PQ, we just use Pythagoras theorem. Okay, so PQ is the square root of 7.5 squared plus 12.99 plus 15 squared equals to 28.98 centimeter. Okay, so that's all for the first subtopic. See you guys later.